All right, welcome everybody to our Bacteria Blitz recap. I first want to say thank you to all of you for joining me and for participating in the Bacteria Blitz. This was our first event like this, and y'all helped it be a huge success. So I'm really, really grateful to all of you. But I know you want to know about your results, so I'll just get right to it. Although I am going to talk about some other stuff before we get to that. So today I'm going to talk a little bit about my organization, the Waccamaw River Watershed, what World Water Monitoring Day is all about. Then we'll get to the results and next steps. I'll try not to take too long to get to your results though. Okay, so what is the Winnyard Rivers Alliance? We get some confusion because I'm the Waccamaw River Keeper, and everybody knows that name, but they don't know Winnyard Rivers Alliance. So Winnyard Rivers Alliance is the nonprofit that I work for, and we cover all the rivers that eventually empty into Winnyard Bay. So we refer to that area as the Greater Winnyard Bay Watershed. And that includes the Waccamaw, the Lumber, the Little PD, the Great PD, the Lynches, the Black, and the Sandpit. And even though we cover all those rivers, we still only have 2 river keepers. There's me, and then there's Jeff on the Lumber. But we are dedicated to protecting clean water in our watershed. And our mission is to make sure that everyone has access to fishable, swimmable, drinkable water. I'm your Waccamaw River Keeper. My name is Kara Schultneck. Probably should have said that at the beginning. I earned my master's in coastal marine and wetland studies from Coastal Carolina University, and then I never left. And I studied fecal bacteria contamination in the Grand Strand. So bacteria and fecal pollution, it's kind of my thing, which is disgusting, but I really enjoy it. And as your Waccamaw River Keeper, I'm responsible for a lot of different things to help ensure clean water, including water monitoring, outreach, education, advocacy, volunteer coordination, and cleanups. So today I'm doing a little bit of a bunch of those. I'm doing some water monitoring, outreach, and some education. And I got to coordinate all you lovely volunteers. So let's talk about my watershed. Excuse me. The Waccamaw River watershed drains 1,600 square miles, and that's over 1 million acres of land. So any water that falls in that area will eventually join the Waccamaw River and move towards Winnyard Bay. So that whole area outlined in white will drain into the river. And the Waccamaw begins as a series of swamps above Lake Waccamaw, which then drain into Lake Waccamaw. And Lake Waccamaw is a Carolina bay. It's really unique. It's one of the few Carolina bays that always has water in it. And it's just really, really cool. If you don't know much about Lake Waccamaw, there's a great video that we did during our Waccamaw conference this year, all about the lake. It's super, super cool. Definitely check it out. So at Lake Waccamaw, that is where the Waccamaw River begins. And it makes its way down across the border and to Winnyard Bay, and it is surrounded by swamps. And it's a blackwater river, so it has that dark color, which is caused by the tannins that leach out of the dead and dying materials throughout those swamps. So it's a really unique river. It's super cool. And it's one of the few rivers that actually runs parallel to the coast. And that's one of the reasons we have an issue with flooding in the Waccamaw, is because it's so low lying and there's not a lot of elevation change. So the water just kind of hangs out. But so that is our watershed. And that is what we focused on for the Bacteria Blitz. And we wanted to celebrate World Water Monitoring Day this year. We don't normally do something big, so this year we really wanted to do it. We partner with Earth Echo International, and they are the hosts of World Water Monitoring Day, which is held annually on September 18th. So we celebrated with our Bacteria Blitz, and some of you use the additional sampling kits, and those are provided by Earth Echo International. And we use those for our youth monitoring program called Carolina Blue Stewards. So if you have kiddos that want to do some water monitoring, that's what they would be using. So why was it so important to host this Bacteria Blitz? We wanted to celebrate World Water Monitoring Day, of course, and we wanted y'all to be able to join millions of other citizen scientists throughout the globe who participated in this event. We wanted to raise community awareness. I know a lot of you already volunteer with me, but there are other community members that don't know what we do. So we wanted to educate them and show them that monitoring is important and that they can do it too. You don't have to be a scientist to do water quality monitoring. Well, you will be a scientist if you do water quality monitoring. Collecting water quality data is always important. The more data we have, the more we can support our local efforts, whether that's advocacy or just having the data, but all the data you collect is always important. And also to protect clean water. If we know that there's something wrong, we can go out and hopefully try and fix it. But hopefully our water quality results will show us that we have fishable, swimmable, drinkable water in the Waccamaw. So we focused on E. coli for our Bacteria Blitz. We mostly, some people collected more data, but what we really wanted to look at was E. coli. And we hear E. coli and we get worried, we think that it's bad, but E. coli doesn't necessarily mean the water is unhealthy. It's not necessarily a bad thing to have E. coli in the water. E. coli bacteria is probably not what's going to make you sick. There are many natural sources of E. coli. We all have E. coli in our guts. All warm-blooded animals do, even alligators do, which I learned a little while ago, which I think is really cool. And we expel it through defecation. So poop. E. coli can mean that there's poop in the water. And so while that sounds bad, if it's not poop from us, it might not make you sick. So if it's from geese or alligators or dogs, there's less of a potential for it to make you sick. But if there is E. coli in the water, it could indicate that there are other bacteria, viruses, and pathogens that might be present that could make you sick. So we use E. coli for a couple different reasons. One, it's really easy and cheap to sample, unlike other viruses. The analysis is fast, so we can get the data processed and get it back out to the communities quickly. There are some methodologies that get it done in 18 hours, which is great. And then we use it because it's EPA's recommended species to use. They've evaluated different methodologies, and E. coli is the best indicator species that has been identified. So that's why we used E. coli. And we created EV coli to show everybody that E. coli isn't so scary. It's not necessarily a bad thing. She's natural. She's supposed to be here too. So here are some numbers to know as we talk about our results. The values that we're going to talk about are guidelines that are created to kind of give an indication to people whether or not water is safe for recreation. The numbers we talk about specifically are for recreation. There are other numbers or values for shellfish and for drinking water and things like this. But we're talking about the river water, fresh water, and whether it's safe for you to go splashing around in the river. The numbers that we use are developed by looking at the potential for a certain amount of people to get sick if they come in primary contact with the water. So it's a little bit convoluted, but basically, if the concentration is below the water quality standard for E. coli, then it's considered healthy for primary recreation, which means direct contact with the water. So the number we've been using is 235. That's what we use for our swim guide. and that is the EPA's value for E. coli concentrations in fresh water. And so that's really important. And then the 36 is just to let you know that that number, that 235, comes from the risk of illness of 36 out of 1,000 recreators are probably going to get sick. So if you have a value over 235 in the waters, that means that if 1,000 people go into the ocean or the river, sorry, then 36 of those people are at risk. So it's not a very high risk, but it's something that we want to consider when we're letting people recreate in these waterways. And then in South Carolina, the value is 349, and that's a daily value. So 235 and 349 are single samples. If you go out, you grab a sample like we did this past Saturday, and if it's above that number, you might have something to worry about, and you probably shouldn't go in the water. If it's below that, you can pretty safely assume that the water is healthy. Okay. So what did we do? We collected samples. First, y'all selected your sites, and you guys did a great job at selecting sampling sites. I really enjoyed seeing some of the different sites that we don't normally sample. So that was exciting for me. Then y'all went out and collected your samples. You collected them that morning and you got them back to us. And then I analyzed the samples. So I brought all your samples back to the lab. I processed them. And the way we process these samples is we use something called IDEX coli alert, where I take your sample, I add media or food to it, and then mix it. And then it goes into these trays that you can see in step 3, and you seal them in those trays. And then you put the trays into an incubator. So basically you're taking that bacteria, you're giving it food, you're giving it a nice warm place, and you're letting it hang out, and it metabolizes that food. And when it does that, it creates a color. So that's how we read our samples back. So to get E. coli, it has to have that glowing color. So you'll see in that picture the glow. That means that that particular well in the tray has E. coli bacteria in it. And then based off the number of wells, the large and small wells, we can calculate a most probable number. So the supposed and pretty factual concentration of E. coli in that sample per 100 milliliters. So we did that. We collected 21 samples. I should say that y'all collected 21 samples. And I don't know if you remember, but my goal was 20 because this year is the 20th anniversary of Winnyard Rivers and the Waccamaw River Keeper. So we made our goal. It doesn't hurt that 21 is my lucky number. And I had 16 citizen scientists out there collecting samples. So that means you guys. And thank you once again. I cannot thank y'all enough. So these are the Bacteria Blitz sampling sites. You'll see that 20 of them were within the Waccamaw River watershed, and then we had one on the Little PD. We had a volunteer who thought she was in the Waccamaw River watershed, but wasn't. And you can see that we have a pretty good distribution throughout the watershed. So that's exciting too. We did a really good job at sampling the whole watershed. Here we go. This is what everybody's been waiting for. These are your results. So as you can see, these are the results for all 21 locations. These numbers, or this graph, shows them just rounded to the nearest whole. And the sites are organized from the watershed headwaters to the watershed outlets. So going from Lake Waccamaw down to Winnyard Bay, and then we have Punch Bowl Landing on the Little PD. So we have a wide variety of concentrations that we found, but you'll notice that red line on the right of your screen, that is the EPA water quality standard of 235, and not a single sample exceeded that water quality standard. So that is really great news. We were glad to see all good values come out of this. So that's really good news. So 100% of the samples passed the EPA's water quality standard for E. coli. One of the things that jumped out to me while I was analyzing the data was how the information or how the data was distributed. So I broke them down into sites that were in Lake Waccamaw or near Lake Waccamaw, because we did sample at Big Creek, and then sites that were in the Waccamaw River main stem, and then our swamps and canals. And I wanted to look at the different water bodies spread apart like this because I noticed that our swamps and canals seem to have higher concentrations than our mainstream sites or our main stem sites. So this is done by water body and then in increasing order of concentration. And it probably an easier way to see this is this graph. And I will say that I took out Half Moon Pond and Punch Bowl for this. So these are those sites. So this is the average concentration by water body type. And again, all of these were below the E. coli standard, which is great. But I saw that we had higher concentrations in our swamps and canals overall. And I think that's interesting, but I also think that it shows how our ecosystem in the Waccamaw River watershed performs its ecological functions. So we have swamps that are able to filter out those bacteria. But some of our swamps have been ditched into canals. So we have stormwater that enters these swamps and canals faster than it normally would. And so we see these higher concentrations getting flushed into these areas. So it makes sense that we would see higher values in our swamps and canals. But the great part is once you get to the main stem of the river, look how low those values are. They're so much lower. And that means that our swamps and our marshes are doing their job and filtering out those contaminants so that by the time they get into the main stem where you're splashing around and playing, you're pretty safe. It's looking good for you. So I think that this is really indicative of how our water body, how it operates in the Waccamaw River watershed, which is really cool. I will say that these were only one sample on one day. And to really back this up, we would need to do multiple samples at, multiple dates at multiple sites over a good chunk of time to really know. But as many of you know, we have data from a lot of these sites going back 10 and 15 years. And these results actually reinforce what we find through our volunteer monitoring program. So that's also a positive thing. So even though we got good results, we also have good data that seems to reinforce what we've been seeing otherwise. Okay, so what does this mean? What do the results mean? Well, low E. coli bacteria in our river is a good sign. It means that our watershed is healthy, that things are working the way they're supposed to, and it's a pretty good indicator that the river is healthy, it's fishable, swimmable, and drinkable. But what do the results not mean? There's always a caveat with these results because the values are not a guarantee. E. coli concentrations can change rapidly. If it rains, you're going to have higher bacteria concentrations. If the water hasn't been moving, you might have higher bacteria concentrations. There are a lot of different factors that impact our E. coli concentrations. And that's really important to remember when you're recreating in the river, when you're doing your sampling. Just practice good, safe, healthy practices. Don't go into the river with open cuts. You wouldn't do that anyways, but just be mindful that there are things in our environment that can make us sick and we need to be careful. So even though these look like good results and we have seen great results all summer, our swim guide report is about to come out and we had great water quality all summer. Out of 167 samples at 12 sites throughout the Waccamaw River watershed over 14 weeks, we only had 5 instances where water quality standards were exceeded by E. coli values. So that's pretty good. That's 97% pass rate. I will take that for the Waccamaw. So keep in mind, these are good results, but they are not definitive and they are not a guarantee. So what now? We had this great event. We got good data. What comes next? If you enjoyed water quality monitoring during this, we have a bunch of different opportunities for you to do water monitoring. We have a volunteer monitoring program that monitors 18 sites along the Waccamaw, that does it twice a month on Wednesday mornings. And our volunteers are awesome. They're the best volunteers in the state. Anybody can fight me on that. But we also have a youth monitoring program, which can be done anywhere from elementary school through high school. And we also have our swim guide program next summer, which you can join and help us do some sampling with that. So we have lots of different opportunities for you to get more involved with volunteer monitoring. If you want to do more to help protect clean water, you can become a member of Winnyard Rivers Alliance. We are a small nonprofit and we make most of our money from membership and grants. And come to our events, come to a cleanup, come to a paddle, just see what's out there and enjoy the river with us. And if you're still wondering how you can get involved, you can always contact me and I will find you something. We can always use volunteers and we love to have you. And with that, I want to say thank you to all of you, from me and from Evie, for helping with this. It was a really great event. Again, when you get that survey, take it, please. But I'm going to stop sharing my screen. And if anyone has questions, I will take those now. So yeah, I will stop sharing and I will come on video. Great. Does anyone have questions? If you do, just chime in. You can also put your questions in the chat if you have them. No questions? Nobody wants to know exactly what their site was? All right. Well, while we wait and see if anybody has questions, we do have our raffle prize. So for participating in this event, we have an awesome raffle for somebody, and they might not be on this call, but they'll still get it. So what you get if you win the raffle is this awesome tote bag, Keeping Rivers Taking Names, Waccamaw River Keeper. You get one of our awesome Bacteria Blitz t-shirts with the lovely Evie. You also get an Evie. How adorable is this little Evie? And then one of our Keeping Rivers Taking Names mugs. So I'm going to draw for the winner. I'm going to see who got it. Put my blue bowl here. I know I should probably have somebody else draw it, but the only person here with me is my dog. All right. And our winner, Jemima. Do you want to tell us who our winner is? I've got Jemima here, but she can't read. Jemima is my dog. Our winner is Brooke. Brooke, congratulations. You won our prize. And you'll be able to pick that up at the office. At some point, I will get in touch. Yeah. But if nobody has questions,
actually, Kara, I have a question, Liz. Yes. Can you explain Keeping Rivers Taking Names?
Keeping Rivers Taking Names is something that, do you remember AJ Taylor, who used to work at the lab? Yes. AJ and I came up with that as kind of a slogan for me when I got the Riverkeeper job. And it's become something that we're taking across the whole organization. And even though it sounds kind of funny, our job is as river keepers to keep the rivers. And we say taking names because part of our job is to hold pollutants accountable. So it's kind of like saying, if you're out there and you're polluting, we will find you. We will take your names. So that's where keeping rivers taking names comes from.
Gotcha. Awesome.
Any other questions? That was a good one, Liz. I like that. All right. Well, if you think of something, you can always email me. Happy to answer questions. If you want to get involved, reach out. Once again, thank you so much for participating in the Bacteria Blitz. It was a great success, y'all. Like, I was so thrilled to get so many participants and to get such good data. So thank you so much. I will be posting this video as well as a blog with our results on our webpage, and I will be sure to share that with all of you. So thanks, everybody. Have a great evening, and thanks for tuning in. Bye, y'all.